We are beginning a new unit on exponential and logarithmic functions. These are our unit essential questions. How do you model a quantity that changes regularly over time by the same percentage? How are exponents and logarithms related? How are exponential functions and logarithmic functions related? Let's begin by exploring exponential models. So through this lesson, you will be able to model exponential growth and decay. First, to warm up. So pause the video and work these three problems, then come back and check your answers. Evaluating x for 3, 2 to the third power is 8. On the second one, we substitute a -1 in for x. So -3 plus 4 is 2 to the first power, or 2. And of course, anything to the 0 power is equal to 1. Our key concepts. An exponential function is a function with the general form y is equal to ab to the x power, where x is a real number, a is not equal to 0, b is greater than 0, and b is not equal to 0. We have a growth factor when b is greater than 1, and a decay factor when b falls between 0 and 1. And there's the asymptote. It's a line that a graph approaches as x or y increases in absolute value. Let's graph y is equal to 3 to the power of x. So we'll make a table of values and then plot our coordinates and connect the dots with a smooth curve. Without graphing, determine whether the function y is equal to 3 times 2/3 to the power of x, whether it represents exponential decay or growth. A is 3, b is 2/3. So since b falls between 0 and 1, this function represents exponential decay. Graph y is equal to 6 times 5/10 to the power of x and identify the horizontal asymptote. First of all, we make a table of values. Then we graph the coordinates and connect the points with a smooth curve. And notice that we get closer and closer and closer to x, but we never quite touch x. So as x increases, y approaches 0. So the horizontal asymptote is the x-axis, where y is equal to 0. When a real-life quantity increases by a fixed percent each time period, the amount A of the quantity after t, which represents time periods, usually years, can be modeled by the equation A is equal to P times the quantity 1 plus R to the power of t, where A is the final amount, P is the principal or the initial amount, and R is the percent increase or decrease as a decimal, and the amount 1 plus R is called the growth or decay factor. You invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? Substituting into our formula, and I notice they have a little a here instead of p, but normally we put p for our principal amount is 1,000 times 1 plus our interest rate written as a decimal, and then here's our time, 6 years. Then we add these together and use our calculator, and it's approximately equal to $1,340.10. Okay, now it's time for you to practice on your own.